let's say we have an arbitrary function y is equal to function of x, which represents a curve. Now we know that f prime x represents the gradient of that curve at any point x. Now this information is important. We can find the maxima or minima of any curve at the point of when the gradient becomes 0, because if we, let's draw an arbitrary curve, which maybe just for example this one. Now we know that by looking at the curve, we know this is maxima, this is a point of minima, local minima here, local maxima, sorry, there, something like that. Now if we don't have the curve, we just have the equation, we can still find the maxima or minima by finding where the curve, the gradient becomes 0. Here it becomes 0, here it becomes 0. So at maxima or minima the gradient becomes 0. So f prime x is equal to 0, and if we solve for x, we get the value where the gradient is 0. So that's fine, but whether the point is a maxima or minima, how do we know that? These points are generally called stationary points, but whether one particular stationary point is a maxima or minima, we have to still find that out. But in order to do that, we can look at the gradients to the left and right of any given stationary point. So let's say we have found that we have found x with our given equation. We have done f prime x is equal to 0, solved for x, and we have found that at x is equal to a, the gradient becomes 0. So we can now find what is the gradient just a little bit on the left of that point where the stationary point is, and on the right of that point, on both sides. And we look at the signs. The value is not very important, the signs. So same towards left and right, and look at the sign. So if it is negative on this side and positive on that side, then we know that this is a minima. That means, let's say this is our stationary point. Here the gradient is 0, but if we go there at this point, and if we go at this point, and if we see that, I'm using a different color, if we see the gradient is negative here and gradient is positive here, that means it goes like this. So this is a minima. That's a minima. So negative on the left and positive on the right. Similarly, if we go, say we have found another stationary point, let's say x is equal to b, where the gradient is 0, so f prime b is 0, we know that. Now we find again what's the sign of gradient. Look at the sign on the left of b a little bit, and the right. D is an arbitrary movement, so a small value of x on the left, and this is on the right. And we look at the signs. So now if this is positive on the right, if it is a maxima or minima, if it's a stationary point, the signs will differ definitely, because this is how it goes, this way or this way. So if it is negative on the right side, that means right side of the, towards the right basically of the stationary point, then it means this is the stationary point. So it is left positive on this side and negative on that side. That means this point is a maxima. So this shows that this is a maxima. So this one, maxima. So that's how we can identify whether a stationary point is a maxima or minima.